orientation. We're still at stage S4, but OWASP was about a poisoned document. This episode is about the store that holds them. A vector database is a database, and most are deployed as one shared index with no per-row access control, holding embeddings that are not anonymized. We'll trace 3 failure modes defensively, then lock the store with isolation, access control, and provenance. Vector and embedding weaknesses, LLM08. The store itself is an attack surface. S4 Inference. Defensive episode, we show the attack flow so we can defend it. S0 data, S1 train, S2 model, S3 supply, S4 inference, S5 agent. Today we light up S4 inference, and inside it, the vector store. Last episode, the attacker poisoned a single document. This time they target the database that holds them all, the vector store as its own attack surface. OWASP LLM08. Most RAG stores are one shared index, everyone's chunks in the same pile, usually with no row-level access control. Keep this picture in mind. Failure 1, no tenant isolation. Tenant B asks a normal question and retrieval hands back tenant A's chunk inside B's context. Same index, no fence. Failure 2, embeddings are not anonymous numbers. With read access, an attacker can partially reconstruct source text from the vectors. Concept only, vectors leak their origin. Failure 3. Anything that can write to the index can plant a chunk. It looks identical to legit data. This is RAG poisoning as a property of the store, not the document. All 3 failures share one bad assumption. The vector store is just a math cache, so it's trusted by default. It isn't. It's a database holding sensitive data. Gate 1. Partition per tenant and enforce row-level access control. Scope every query to the caller's tenant, so retrieval only ever sees its own chunks. Gate 2. Treat embeddings as the sensitive data they are. Encrypt them at rest and gate who can read the vectors at all, so inversion has nothing to work from. Gate 3. Stamp provenance on every chunk and validate on ingest. Only trusted attributed writes ever land in the index. Rogue writers are held at the door. Same store, 3-layered gates. Tenant B's query returns only tenant B chunks. Cross-tenant reads, embedding inversion, and rogue writes each hit a gate and stop. Each tenant's data stays its own. You lock the store. Next, do you even know what's actually in your AI? Every model, dataset, package, and tool. AI bomb and model signing. Break it on the board, not in prod. So, a shared store with no access control leaks one tenant's chunks into another's context. Embeddings are not anonymized, so read access partly reconstructs the source text, and an unvalidated write path lets anyone plant a chunk. Lock it by partitioning per tenant with row-level access control, treating embeddings as sensitive data, encrypted at rest and read-gated, and stamping provenance on every chunk. Your vector store is a database. Secure it like one.